Hey everyone, welcome back to the channel. Or if you're new here, smash that subscribe button because today we're diving into the most mind-blowing objects in the cosmos. General relativity, the 1915 upgrade, says gravity also slows time. The deeper you are in a gravitational well, the slower your clock ticks compared to someone farther away. Or the opposite, you watch your friend fall toward the event horizon, and from your spaceship they appear to freeze in time forever. A single hour for you equals centuries, maybe millennia, for the rest of the universe. That's not sci-fi, that's physics. And today I'm going to prove to you that black holes are the closest thing nature has to actual time machines. Not the dial-a-date kind from movies, but literal, proven, time-warping monsters predicted by Einstein and now confirmed by telescopes, gravitational waves, and even the GPS in your phone. Let's go! Black holes. The universe's ultimate time warp machines? First things first, what even is a black hole? A lot of people think it's a giant cosmic vacuum cleaner that sucks everything in. Wrong. If our sun suddenly turned into a black hole of the same mass, Earth wouldn't get pulled in. We'd just freeze in the dark, still orbiting exactly the same. The difference is compactness. A black hole packs the mass of millions, or even billions, of suns into a region so tiny that, once you get too close, the gravity becomes inescapable. That boundary is called the event horizon, the point of no return. Cross it, and nothing, not even light, can climb back out. This is the actual photo we took in 2019. That glowing orange donut? That's superheated gas swirling around a shadow 6.5 billion times the mass of our sun. How do they form? Massive stars, 20 plus times heavier than the sun, run out of fuel, collapse, and go supernova. If the core left behind is heavy enough, gravity wins completely. No force in the universe can stop it. The core shrinks past the neutron star stage, past the Schwarzschild radius, and becomes a black hole. And here's the crazy part. Once formed, a black hole forgets almost everything about the star that made it. According to the no-hair theorem, it only remembers three things: mass, spin, and electric charge. Everything else, the star's chemical makeup, magnetic fields, poof, gone. Black holes are the simplest objects in the universe, and the most extreme. Now let's talk about time. Everyone knows Einstein said time is relative. But most people think that only happens when you're moving near light speed, special relativity. General relativity, the 1915 upgrade, says gravity also slows time. The deeper you are in a gravitational well, the slower your clock ticks compared to someone farther away. We see this every day. GPS satellites orbit 20,000 kilometers up, where Earth's gravity is weaker. Their atomic clocks run faster than clocks on the ground by about 45 microseconds a day. If engineers didn't correct for Einstein's equations, your maps would drift by 10 kilometers daily. Real-time travel, 38,700 nanoseconds at a time. But near a black hole, gravity isn't just strong, it's infinite at the event horizon. So time dilation goes completely off the charts. Here's the famous thought experiment. You and I are hovering safely far from a black hole. I decide to take a quick dive toward the horizon and come back. From your point of view, as I get closer, my ship's lights turn redder and redder, gravitational redshift. My movements slow down like a YouTube video buffering. When I reach the event horizon, I appear to freeze completely. You'll never see me cross. I'll fade away, frozen in time, for billions of years. From my point of view, everything feels normal. My clock ticks fine, my coffee stays warm. I cross the horizon with no drama, no bump, no sign saying, "Welcome to the black hole." I just sail right through, and then, very quickly, get stretched into atomic spaghetti by tidal forces. Both stories are true at the same time. That's relativity. And that means, when I fly back to you after my quick trip, you might be long dead. Centuries could have passed while I aged only minutes. That's one-way time travel into the future. No flux capacitor required. Remember Interstellar? 1 hour on Miller's planet equals 7 years back on Earth. That wasn't Hollywood exaggeration. Christopher Nolan had physicist Kip Thorne as science advisor. Okay, but it gets weirder. Because most black holes spin really fast. And spinning black holes drag space-time itself around with them. An effect called frame dragging. NASA's gravity probe confirmed this around Earth in 2011, but near a black hole the twisting is insane. There's a region called the ergosphere where space-time spins faster than light. You can still escape, but you cannot stand still. The fabric of reality literally forces you to spin with the hole. Now, about that spaghettification I mentioned. Gravity gets stronger the closer you are, so your feet feel way stronger pulled in your head. For small stellar mass black holes, you'd be torn apart long before reaching the horizon. For supermassive ones like Sagittarius A** in the center of our galaxy, you could cross the horizon alive, but you'd only have a few seconds before the singularity turns you into plasma. And the singularity? That's where physics breaks. General relativity says everything gets crushed to a point of infinite density. Infinite. That word is physics screaming. I don't know what happens here. Because at that scale, quantum effects must take over, and we don't have a working theory of quantum gravity yet. String theory, loop quantum gravity, they're all trying to solve the riddle hidden behind every event horizon. So are black holes time machines you can use to go backward in time too? That's where wormholes come in. In 1935, Einstein and Nathan Rosen realized the math of black holes allows bridges connecting distant parts of space-time. Einstein-Rosen bridges, aka wormholes. Problem: the original versions collapse instantly. To keep one open so a human could pass through, you need exotic matter with negative mass, stuff that falls upward. We've never seen that in bulk. The Casimir effect gives tiny hints, but nothing usable. But let's say a super advanced civilization figures it out. Kip Thorne and others showed that if you take one end of a wormhole, accelerate it to near light speed, or park it near a black hole, time dilation makes the two mouths age at different rates. Step through the old mouth and you pop out years, or centuries, in the past. Congratulations, you've built a time machine. Of course, this immediately creates paradoxes. Kill your grandfather you're never born who killed him? Physicists have three main escape routes. 1. Stephen Hawking's chronology protection conjecture. The universe hates time machines and destroys them with quantum explosions before you can use them. 2. Novikov's self-consistency. You can go back, but the universe won't let you create paradoxes. You'll always fail to shoot Grandpa.
3. Many worlds. You don't change your past. You branch into a new timeline. We don't know which is right.
There's also the black hole information paradox, Hawking radiation, holography, but we're running out of time. So here's the bottom line. Conclusion time. Black holes are not portals you can dial to 1920s Paris, but they are the universe's ultimate proven time-warping objects. They stretch seconds into centuries. They freeze falling astronauts at the horizon forever. They drag entire space-time into a cosmic whirlpool. And at their hearts, they hide the breakdown of physics itself, the place where our two greatest theories collide and demand a new understanding of reality. We photograph them. We've heard them collide in gravitational waves. And every new observation confirms Einstein was right. Time is not the same everywhere. It's a physical thing that gravity can bend, slow, and maybe, just maybe, one day let us fold. So next time you check Google Maps, and it knows exactly where you are, think a black hole. Because without correcting for the way gravity warps time, none of it would work. If your mind is properly melted, hit that like button, drop a comment. Would you take a one-way trip near a black hole to jump 1,000 years into humanity's future? And subscribe with notifications on, because next week we're tackling whether the universe might be inside one. Thanks for watching, clear skies, and I'll see you, well, whenever time decides.